For hierarchical routing with 4800 routers, what should be the optimal size of routing table in terms of total number of entries? Hierarchical routing table is hierarchical routing is 3-layer with clusters, regions, and routers. One hypothesis is given: the solution with k clusters of k regions of k routers is close to optimal. So we need to find out the optimal number of entries in a routing table. Normally in a routing table, if you do not follow the hierarchy in the routing table, then we need to have an entry for every router, every other router. For example, if there are 10 routers, from R1 to R1, R1 to R2 and so on, for all the remaining routers you should have an entry. For the same router, entry will be 0, but entry should be made. Total, for n number of routers, n number of entries will be required. If you have 4800 routers, normally if you do not follow the hierarchy, then if you don't divide the routers into regions and regions into clusters, something like that, what is given as a 3-layer hierarchy. So in this case, we need to have the entry for every router. So when you divide, only, for example, if some set of routers are divided into regions, only the region number will be mentioned to go to that particular router in that region. If some regions are divided into clusters, only we need to mention the cluster number only. So we need to find out the total number of entries. So here 4800 routers are there. 3-layer means cube root of 4800 we have to find out. So exactly, or else it is close to optimal. Cube root of that value is close to optimal. So that we can 4800 can be divided into something like 15 clusters, where each cluster is containing 16 regions, where each region is containing 20 routers. That is 15 into 16 into 20, total you get 4800. That is one case. Or we can have 20 routers, where a collection of 20 router is divided into region. Like that we can have 16 regions, and region are divided into clusters. That is 15 clusters. So like that also we can divide. That is 20 clusters, 16 regions, and then 15 routers. Both of them. So either way, if you add all of this, for 15 routers you have 15 entries, for 16 regions 16 entries, for 20 clusters 20 entries. Total we will have 20 plus 35, 35 plus 10, 45, and then 1, 51. Total 51 routers will be there. Option A is the right option here. That means 51 number of entries will be there in the routing table.
Construct a code converter to convert BCD to XS3 code using a different programmable logic devices. Okay, what will be the size of the room if the above code converter circuit is implemented using ROM? First of all, ROM is nothing but number of address lines and the number of output data lines. Okay, so here BCD means the number of BCD is present from 0 to 9. So there are 4 input variables are required, means the address variables are 4. And similarly output also, if the input is 4, suppose 0 0 0 0, the corresponding XS3 code is 0 0 1 1. This has to be present in the memory itself. So if this particular address we are giving, this data is available at the output of the ROM. Hence it is going to be 2 by 2 power 4. This 4 is nothing but address bus width into 4. This 4 is the data bus width. Hence option B is correct. Here first of all I am taking variables BCD code as A, B, C, D, and XS3 code as W, X, Y, Z. So suppose if it is 0 0 0, corresponding code is 0 0 1 1. 0 0 1 0 0 1 is equals to 0 1 0 0. Similarly till 9, 1 0 0 1 is nothing but 1 1 0 0. So if we solve a key map for each variable in terms of these, so we will get W as A plus BD plus BC, whereas X is BC bar, D bar, plus B bar D plus B bar C. Why is C exclusive D, that is C bar D plus CD bar. Z is equals to D bar. Here, if we observe W, X, Y, Z expressions, there are no common terms in between them. That means there are no product terms shared. That is option is correct.
Correct answer question. A local area network operates Ethernet with CSMA-CD mechanism and runs at a rate of 16 Mbps and cable length is 2 km. Assume that the signal speed on the cable is 1 lakh km per second. What is the minimum transmitted frame length in bytes? So here we need to find out propagation time and round trip time. Within the round trip time, how many bits we are able to transfer. Based on that, we need to find out the minimum frame length. So here we can say that is what is the number of kilometers per 1 second the cable can travel. That is 1 lakh kilometer. For one solution is like this. For 1 second it can travel 1 lakh kilometers. 1 second means 10 power 6 microseconds. For 10 power 6 microseconds, 1 lakh kilometers. For 1 kilometer to travel, it will take 10 power 6, 1 lakh means 10 power 5. So 10 microseconds it will take. So this is 10 power 6 microseconds, 1 lakh kilometer. For 1 kilometer, 10 power 6 divided by 1 lakh microseconds. So 10 microseconds. What is the cable length? It is given as cable length is 2 kilometers. For 2 kilometers to travel, it will be 2 into 10, 20 microseconds is the propagation time. Round trip time is equal to 2 into propagation time. So it will be 40 microseconds. 40 microseconds is the round trip time. So now within this round trip time, how many bits we are able to transfer? That should be the minimum frame size. So here, what is the running rate of this LAN? 16 Mbps. For 1 second, 16 megabits. 16 into 10 power 6 bits for 1 second. 1 microsecond, 16 bits. 40 microseconds, 40 into 16 bits. 640 bits. 640 bits, we need to find it in bytes divided by 8. So we'll get 80 bytes. So 80 is the right answer. Option D is the correct option here. So this is the first question. So now there is one linked question for this. If we use sliding window protocol with selective repeat for the flow control with 3 bits for the frame sequence number, then what will be the maximum number of bytes that can be transferred to the destination using minimum frame length above without waiting for the acknowledgement? So we have to use the solution we got in the above case. The minimum frame length we got is 80 bytes, that we have to use. If you have 80 bytes for that frame length, then how many bytes you can transfer without waiting for an acknowledgement? Selective repeat. Number of bits we are using is 3 bits. When you use 3 bits, maximum number of frame sequence number 2 power 3. That means 0, 1 and so on 7. 8 different numbers we can have. Again after that it will repeat 0, 1, 2 like this. But the window size in selective repeat will be half of the 2 power n divided by 2. That is, it's 8 by 2. We will get around 4 numbers in the sliding window. So that means there are 4 frames. 4 frame sequence number. Let it be some 0, 1, 2, 3 for example. So every frame already we decided 80 byte. So 4 into 80, 320. So these many bytes we can transfer without waiting for any acknowledgement, because all the frames can be transferred in the window. That is option B is the right option.